Welcome back to the PostGIS tutorials. In the last video, I already showed you how to get started with PostGIS. In this video, we're going to work with geometries with PostGIS. So first, let's go to the website to download the notebook example we're going to use in this video. You go to postgis.gshub.org and then click number 4, working with geometries. Then you can click the upper right corner. Download this notebook to your computer, any directory you want. I'm going to download to my downloads folder. Click save, and after that you can open Jupyter Notebook. So I'm just going to right click, open the terminal, and then just type conda activate SQL. So this is the conda environment that we created. Then just type Jupyter Notebook, hit enter. And just after a couple seconds, you should have the Jupyter Notebook open. Then just click the notebook example. So in this one, we're going to go through some of the things that how you can deal with geometry. And you can click the table of content if you want. So in here, we have 10 subsections. Before we use this one, I'm going to show you you can also use QGIS or PGAdmin to deal with geometry, because since I'm teaching, so it's better to have all the command lines type before I'm teaching, so I don't need to type this. It's going to save a lot of time. But if you're just learning PostGIS by yourself, and if you want to type those commands, it's better to use PGAdmin or QGIS, because you have auto completion. Right now within the Jupyter Notebook, there's no auto completion, so you need to make sure that you type each command or SQL statements correctly. Otherwise, you might run into errors. And auto completion is a nice feature to have. And so if you use PGAdmin, you might already know this. And so next, I'm going to show you some of the things that you can do you directly within the PGAdmin, right? So if you go to, after you open PGAdmin, then you click the database. So the NYC database is the one that we created in the last video. And then you want to go to schemas, public, and then tables. So all the geometries, all the tables, spatial data tables will be located within here, right? So we loaded 5 tables. The spatial reference systems, this one was the built-in one when we create the PostGIS extension. Also from the functions list, if you click, right now we have 695 functions. So these functions are designed for the QGIS and for both PostGIS, and this is why it can handle all kind of spatial objects. Regular PostgreSQL database, they cannot handle spatial database. For example, if you go to the default one, PostgreSQL, and then schema, if you look at the functions, there's no functions in here. And so this is very powerful, because right now we have hundreds of functions that we can use to analyze spatial data. And we will talk more about these functions later. But for now, if you select, for example, one of these tables, you can just simply, let's see this one, right click, and then you can just view the data, right? So in this way, you don't have to write SQL command, but essentially it's the same. Whenever you do anything here within the PGAdmin, you click the button, you do anything. It's actually behind the scene. It's also executing SQL command. So this is how you can view the data, and this is the source code SQL statement used to query the data. And the spatial reference, if you look at this one here, we have thousands of spatial reference, right? So if you scroll down, I think you have a couple thousands. I don't remember exactly. Okay, the number of records, but you can also select the count if you want to get how many actually within the database. Also, you can so if you want to query, you can go to the tool, right? And you can select the query tool from here. So for example, if you were trying to figure out like how many lines of record, how many records within the spatial reference database, we can just select, and then you can just type count parentheses star from, then you can control space. If you type control space, it's going to show you the available tables that you can use to do the query. So in this way, you don't have to remember exactly the name of the table. So what we are trying to do is to find this one. Then you can press F5 or just click this button to execute. So in this case, we have 8,500 records. So there are a lot of spatial reference system IDs. If you're using the Jupyter Notebook, then you need to type correctly the name of the table. So sometimes it might be very annoying. And so this is a good way if you just get started and you want to use some auto completion features. It's better to use pgadmin. But for teaching, for me, because I have to type so many commands, it's better to put all of them within one Jupyter Notebook so that we can just go through the examples without having to you have to see me typing and sometimes a lot of typos. So this is better for me. Okay, so this is how you can use pgadmin. You can do some auto completion, but you can also use QGIS. So next, let me open QGIS here. And last time we already connect the database to NYC database, right? So if you select this one and you will click the public, we already have 5 features that we can load it to the map. So for example, if you just double click, you should be able to see this one. After you do select transformation, you just click OK. Then you have the data layer loaded to the map. Okay. So similarly, you can also use the DB manager. So you click the database, DB manager. And from here, you can select the PostGIS, then NYC, right? Public schema. Then you should be able to see all the table. Similarly, for this one, like spatial reference systems, this is the table that we use in pgadmin. But you can also do the query here directly within the DB manager. What you need to do if you want to query anything, you can click this icon. So it's going to open up the SQL window. And from here, you can start typing. And this one here also has auto completion. For example, we can do the same thing. We can just type select. As you can see, when you type anything, match the command, it will show you the available list. And then you can just you can continue to type, or you can select. And then you can, for example, type count, right? You don't have to, you just type 2 to 3 characters. Then it should show you the available function. Then you just hit enter. So in this case, we want to find out how many rows within this table. And then the start, this one, from, right? And you can start typing the name, spatial, right, reference systems. And then you can click this one here, execute. You can also use this keyboard shortcut, Control R, right? Control R, then you can execute. So you get the same result. This one is that pretty much if you're using QGIS, you don't really have to use pgadmin because everything, all the command, you can do it in here. And the nice thing about this is that it has auto completion. So it's better than the pgadmin. As you can see, you can recognize the functions, recognize the table name. Very, very nice. So, and then you just execute. You can also save this, for example, the query, you can save and then you can load the query later. Similarly, for example, they say you can type, if you don't know the name of those, you can just type star, and then from the table, we can just Control R again to see all the records, right? So this case, we have SRID and the str text. This one is a long, so where no text represent spatial reference. Also have PR project for text. This is the 2 common format used to represent spatial reference. So you can see from the table here, and you can use this to do additional analysis. This one here is just a non-spatial table. It's just a regular spreadsheet, but you can also do that. You can query, for example, using spatial data. So you can click this one, and then you can select the table. You should be able to look at the table, and this is the geometry column, right? Right now it's just showing the type, but later I'm going to show you how you can actually get the coordinates if you want. You can also preview, and so here, right? So it's much better than the pgadmin because pgadmin cannot show you the geometry. So within the QGIS DB manager, you can query the data, you can see the table, you can also preview the data nicely. So again, you can click the SQL window and you just type select, By the way, so the SQL, all the keywords and statements or command lines, they are non-case sensitive. So lowercase and uppercase, they're the same. But usually the convention is to have those reserved keywords uppercase. But in here, in this QGIS, everything is just pretty much lowercase. So you can directly use this if you want. And then select star, for example, from. In this case, we're trying to do the NYC neighborhood. Then Control R. You should be able to see all the records displayed in here. And for the geometry column, you will see here we have a long string. So this one actually is a binary string used to represent geometry. And we can convert this one to other representation if we want. I'm going to show you later, okay? And this is how you can use the DB Manager and QGIS to also do spatial query. Next, let's go back to the Jupyter Notebook because we're going to use a lot of examples. So it's going to save me time without having to type those source codes. Okay, so we're going to use the same thing like we used last time. For the first section, we always be the same because we need to connect to the database. Before we connect to the database, you cannot query the data, right? Because in QGIS or PGAdmin, we already authenticate. So that's why you can directly just type those SQL commands. But in Jupyter Notebook, you need to make sure that you always run this first section to connect the database. Okay, so you can select here and just run all above, and then it's going to connect to the database. Next, we can create some geometry. So the first example here, because in the Jupyter Notebook, you can in the PostGIS, we can, there are different types of geometries, right? So if you have used ArcGIS or QSGIS, you might already be familiar with something like this. So in geometry, we have point, we have line. This is also called line string, polygon, and also collection. For polygon, sometimes you might have multiple types. So if you have a hole within the polygon, then the polygon is going to structure is going to be different because you have internal ring within the polygon. And so in here, this simple SQL statements is used to create a table. So the first line here is create table geometry, and then within the geometry have two columns. So basically for the attribute table, how many columns do you want? So the first one here is name, and then the type, the data type is character. The second column is geometry. If you want, you can also go to the PGAdmin. Then if you click, for example, the types in here, this is shows you in PostGIS what kind of geometry you can create, right? So we have the so-called geometry. So this is the common one that you might be using. There's also the other one called geography. So this one is more like in the 3D representation, the globe. And most of the time we're using just the plane geometry, and we'll be using this one. But there are also some other types you can use. You can also look at the view. So the view basically is a table created based on query. You can use the same thing just like a table, but this is actually, you can think about just like a virtual table. And if you want, you can right click, view data, all rows. This one gives you all the tables within this database, right? So this is the database. Within the public schema, we have five tables, and in addition to the spatial reference table. So in here, you will see you can have the table, the catalog. This is basically the database, the schema. So all these tables are within the public schema. It all has the geometry column, and the coordinate dimension is 2 dimensional, right? So in 2D, whether it's a point, a line, or polygon, they are all within the 2D dimension. We also have the SR spatial reference ID. This is the number and also the type, right? So we have point, we have multi-polygon, we also have a multi-line string here. Okay, so next, let's get back to the Jupyter Notebook. So in this example, I'm trying to create a new table. So you can use the command create table. This is the geometry, is the name of the table. Then we have 2 columns. Also, after we create this empty table, we want to insert some values into the table. So because the table, we have two columns, right? We have the name, we also have the geometry. So when you pass in the new values, you need to have the name. You also need to have the geometry. So in the geometry here, it's basically a string, and then you can indicate the type, right? So if this is a point, you want to have parentheses and then 0, 0. So it's separated by space. So the XY, right? Also for the line strings, a line basically is a set of points connected together. So if the string, you also have going to have a pair, XY, comma, XY, comma. So this case, it has 4 points. Also for the polygon, it's the same thing, but the polygon is closed. You can have the same number of points, but the polygon is closed. So the starting and the ending is the same point. Also, you can have polygons with a hole. In that case, you want to have like separated by comma. So the first one here is the external ruin, and this one here is the internal one. Again, they are supposed to be closed, right? So for example, this is like 1, 2, 3, 4, 5 points. And similarly, internally also have internal. So this polygon represent the whole. And also you can have multiple geometries within one record. So this is so-called geometry collection. You can have a point, you can have a polygon or line together within one collection. After that, we select and display the results. So by the way, let me clear all the output because some of those are from the previous results. So I'm going to just view, maybe edit. No, this one here. Let me just clear all the outputs and run this one more time. So I'm going to run all above. So after you have this one, we should have the new table created. You can go back to the PGAdmin if you like, and from the table, right click, refresh. Now you should be able to see this geometry here, right? And you can right click, then view the data, all rows. Right, so here right now we have this table has 5 records, and we have 2 columns, the name and also the geometry. Like I said, the geometry column, this one is only PostGIS can handle, and this is basically a binary representation. You can see here it's a very long string. Right now it's a kind of simple geometry, simple shape, but you still see this kind of very long. But if you have really real geometries, it's going to get much longer. So this is how it's actually being represented using binary format. Once you have this, then you can do query. For example, right now, after you create this table, and this is basically, you can think about this is right now a shape file, but you can have like a shape file. Usually you can have only one geometry type, but in PostGIS you don't have to, because each record can have a different geometry. So in this case, we have 5 types, and then each type, each line of records basically is a geometry, and you can start using some spatial functions to actually work with this kind of geometry. For example, you can use this one, select name, and then STS text. So this function comes from the PostGIS function, then apply on the geometry column. So, and then we're going to select this from the geometry table. So this is what you can see. This one right now here, you can see the name and also the STS text. And this one is better than the PostGIS, right? So if you see from this table, it looks like this. And this one you cannot really comprehend like what exactly it's going to look like when you load the data. So, but you can use this function, STS text, to let me also copy this one here. If I paste, let me see here, right click, and then query to, you can paste this one, and then F5, you should be able to get the same result. So this is how you can utilize PostGIS functions to interpret some of the geometry column. If you want to see learn more about the see more functions, you can go to, again, here the functions, and then click this one. If you scroll down, you should be able to find the one STS text. All right, so this one here. You can also geometry the text. You can have an integer. Basically, you can limit the number of strings you want to print out. So this case, some of those are short because for the point, it's just 2 points. You have line string. You might notice, so this is basically the string that we pass in to create the geometry. Once the geometry is created, it's saved as binary. But if you want to see reverse, like go back to see what those texts are, you need to use this one as the STS text actually to do that. Next, let me quickly go back to here to show you how you can use the DB manager to do the same thing. So again, I'm going to go to the NYC public data schema, and then I can open the SQL query. In this case, I'm going to select name and then st underscore as text, right? And then parentheses. We're going to apply in the geometry column from geometry. So the geometry is the table. Then Control R. Okay, so you should be able to get the same result. If you don't use the st as text, you just type the geometry. Then you will see the binary, like long binary string. So GEOM, right? Control R. And if you scroll, right, so this is the long string. How the geometry actually is being stored and represented in the table format. It looks like this. Okay, so this is about the creating the geometry, and you can also look at the metadata table. I think I already showed you this one earlier in the PGAdmin, right? So you can select the spatial reference system table, and I only print out 10 records, but you can but it has 8,500 coordinate system reference IDs that you can utilize, and this is a long list. Everything we later when we define spatial reference ID, it will be one of those from those 8,500. You can also select the geometry column, and that's the one also I show you over there. So this one here, if you within the database you want to see what tables within the database, you can use this one. It will also show you the type of the database, for example, the specific table. And so you go back to this one more time, quickly show you here. It's under the view. Okay, it's under the table, so it's under here view. So again, this is a table created based on query, and you can think about just like a virtual table, and right click, view data, all rows. You should be able to see this one here, all the columns, and the same thing that you see from the Jupyter Notebook here. This is basically just a good summary of all the tables within the database. So we have right now we have 6, right? So we have NYC. The last one is the one that we just created. This one right now does not have a spatial reference ID, and the type is basically geometry because we have multiple geometries within this table. For other tables, it's just only a single geometry type. So you will see the type here is point, line, or multi-polygon. Next, you can also use this function, for example, st geometry type, st number of dimensions, and also st SRID, so the spatial reference ID from the geometry. So the geometry is the one that we created, and we can take a look at the results, right? Earlier we create a point, a line, a polygon with a hold, and we also have a collection, right? So everything here just show you the geometry type. Here the geometry type, that is the point, line, polygon, and these two actually are the same, right? Although it's a polygon and also polygon with a hold, but they're still polygon. Also the last one here is geometry collection, and they're all 2-dimensional objects, not three-dimensional. Spatial reference ID, they are all 0 because we didn't specify the spatial reference ID. So this is how you can query the data. Next is about points. So points basically is the simple representation about a single location. Usually it's represented by XY, right? XY location. In this case, we can, for example, we have a point in the geometry table. we can use the STS text to figure out the XY location. So, and where name equal to point. If you go back to the earlier, when you create the table, right? We have the table, we have 5 records, and the first one is point. This is the name, and this is the geometry. So if you go back to this one, if you execute, it will show you STS text. This is the point. So this is exactly the text we use to create the geometry, representing the location x equal to 0, y equal to 0. And right now, because we don't have the spatial reference ID, this one is just a relative point starting from 0 and 0. You can also apply the STX and STY to get the coordinates, because this one here right now is a pair, right? It's a point XY. So if you apply these two, you're going to have to separate into 2 columns, because if you have this, it will just in within 1 column. Sometimes if you want to, for example, extract the X and Y from the points into separate columns, then you can use this way. Select STX, right? Apply on the geometry, and then Y, apply on the geometry. Then you have 2 columns, like 1 point and 1 point. If you want to, for example, you can do this one. They say for the NYC, let me look at this one here. Look at the tables, right? And they say the NYC subway station, right? So the subway station, and this one basically is a point geometry. So how can we actually get the point? If you right now right click and then view the table, all rows, right? It will show you the records. I'm not sure if you have a longitude or latitude or not. No, we don't. We only have the address. So within the geometry column, this is where all the points location are being stored, but we don't actually know where exactly is the point location. So similarly, we can go to the DB manager and clear this one here. If we want, we can actually extract the coordinates, the location from this point. So again, I'm going to click the subway station and then the table. Right. So what we're trying to do is to get the longitude and latitude, and let's see how we can do that. You can select from here, select, and then you can STX, right? GOOM, also XTY GOM from NYC subway station, Control R. Then you should be able to see this one, ST and STY. So this is basically the coordinate, because this is using the UTM. You will see the coordinate, these 2 columns. This is how easy it is to actually extract the coordinate. You can also convert this to longitude and latitude if you want. I'll later show you how to actually to do the conversion to different coordinate system. But for now, this is the way that you can use to extract coordinates from points. What else? Okay, so next one. Okay, this is basically what we did earlier, right? Select the name. You can also STS text to have these 2 columns from the NYC subway station, right? So it basically shows you the point, and also within there you have the coordinate X and Y, the coordinate pair, and shows you the data. So columns and as text. Again, everything comes from the geometry column. If you have the geometry column, then you can query the data and to display, customize the format you want to see. Next one is about line strings. This is just polygon. Polyline in ArcGIS is called polyline, and the polyline you can have a simple one or complicated one. Complicated one means it can sometimes the line can close. So basically, the starting point is the same as the ending point. In this case, we want to deal with, for example, this example that we created earlier, right? You can from the geometry table and select the line string, the records. So this one here shows you the text. We have basically have 4 points, 1, 2, 3, 4, and this is a simple line object. Once you create the object, you can apply the PostGIS functions to, for example, get the length. You can also get the starting point, get the end point, and also show you how many how many what's the number of points within that geometry, right? So here this example shows you the length. We have, just think about here, 0 0 1 1 2 1 2 2. So basically you have the points of four corners for this line. You can calculate the length if you want, right? So it's going to show you, okay, 3.4. There's no unit. This is just a simple representation. You can also calculate, for example, the starting point if you want. And similarly, you can just copy the function. And then you be pasting, you just need this starting point. Right? And you can also have the ending point. And then control enter. Right? So this shows you the geometry. Again, this is just the point, and it's a binary format, so you cannot really see the point. If you want, you can use st, right, as text, and then parentheses st as text. Now I have these 2 points, like 0 0 2 2. If you go back to the one we used to create the record, right, 0 2 2. So this is the beginning, this is the end. It can also show you how many what's the number of lines within the geometry. So again, if you want, you can copy this one and then paste in here, comma, and geometry. So how many points you want to expect? Because we have 4 points, so the number should be 4. st is number of points, so number 4. So this is how easy it is. You can apply functions to deal with this line string geometry. Okay, so next one is about polygon, and polygon basically is a collection of points to connect together and to form a closed ring. So within here you have simple polygon, but you can also have some complicated polygons with holes within the polygon. And in QGIS or in PostGIS, you can also create geometry polygon. And so in this example, we're going to query the polygons that we created earlier. We have 2 polygons. The first one is a simple one, and the second one is a complicated one with a hole within the polygon. And this is how you see here, we have 2 rows of records. After you create the geometry, then you can apply different functions to the geometry. You can calculate the total area. You can calculate how many, the number of rings within that geometry, and also the external, the internal, and also the perimeter of the geometry. So next, let's try to calculate the total area, right? So the first polygon, the area is just 1. The second polygon is 99. But you can also, for example, you can, if you want, you can calculate the number of rings, right? So we can do here to go to the end, and then comma, geometry. That shows you how many rings. So it's just 1. The second one, because we have an internal one, so the number will be 2. But you can also apply some of the functions. So similarly, you can just paste the function to here and then to continue. The last one here is about collection. So collection is, you can have within the geometry, you can have multiple geometries. So this thing is a collection. We have point, you have line, you can also have a polygon all together. And the last one that we created in that example is a collection, right? So you can execute, and so the collection, we have a point in that, we also have a polygon within that one. Similarly, you can apply the st area, the length, also geometry, this into the to apply to this one to find out, for example, how many geometries are within this type. And maybe I can just take a new example here just to show you. So if you want, you can type comma, and then, for example, if you want to find out how many geometries within that geometry. So geometry can be a collection. So in this case, you want to expect how many? It's going to have 2, because we have a point. We also have a polygon within there. You can also calculate the area or the length. So S geometry n returns a specified path. That means n, if you can select for the first one, you can select the second one to return, basically extract the object from the geometry. Okay, so we have covered those four common geometry type: point, line, string, and polygon, and also collections. And next two sections showing you how to do the conversion, because the data can come from different format. And so the OGC standard, so we also have a well-known text. You can click the link here to take a look at the definition. So basically is a text representation of geometries or coordinate reference systems. And this is the one that I showed you earlier, that if you want to see, for example, the text representation that people can interpret, then you might want to use this well-known text so that people can understand what that geometry represent. Is it a point, is it a polygon, or is it a line? Also, for the spatial reference coordinate systems, similarly in the here, if you right click and then view all rows, you should be able to see basically the spatial reference text. So this is basically well-known text. Also the other one here, because when you read this one, you can actually interpret and understand that. If this binary text, you cannot really understand directly. Okay, so this is how we can do the conversion for different format. You can also convert the data, the geometry, directly to GeoJSON. And we talk about this later in this course, how to actually to load the data GeoJSON to the map, to the iPyLeaflet Jupyter Notebook. And this one shows you some of the example here. Also, this is if we have not covered this one, the two hyphens, this one represent comment. So comment, this is basically you can write, sometimes have something to explain what you're trying to do, and this will not be executed. So comment basically in Python just like control slash, but in SQL is the two hyphen here. And so if you execute, right, so we have 5 command lines. Each line here actually represent a comment for this one. So, and this is how you can specify. For example, you can set the spatial reference. You can also convert, create geometry from text. Also can specify the spatial reference ID. So in this case, we're trying to create a point, and the spatial reference ID is 4326 WGS84. And right after you create this one, become a geometry point, then you can do spatial analysis with the points. Okay, so the last one here is how to casting from text. This is just a type conversion, right? So for example, in SQL, if you want to convert a number to a string, then you can use this 2 colon. So select and then 2 colons. So this 0.9, right? This is basically a number, and then double colon, it become a text. It become a string. And now you will see here, this is the column and this is the value. Similarly, you can convert a number, but you can also convert directly a string into geometry. So in this case, we have a point, and then like we did earlier, you have X and Y, and this is basically a string. You can directly convert this one to a geometry object. So this execute, and then right now if you see this is a binary format. You cannot comprehend this, and this is right now becomes a geometry object, and then you can do spatial analysis. If you want to specify a spatial reference ID, you can do that this way. So within the single quotes, you can have spatial reference ID equal to the EPSG number, and then semicolon. After that, you can put the coordinate, the points into the geometry. And this is how you can also create a geometry like this. Lastly, here are some of the functions that might be useful. Some of those we cover in this video. For example, how to calculate the area for a geometry, how to show return the well-known text representation of geometry. This one is without the metadata, so without the spatial reference ID. But you can also use this one here, the extended one. This one support the spatial reference ID. So as EWKB and also EWKT, right? So this is all you can do. If you want, you can just directly use the STS text. And this one again, it doesn't support. It doesn't have the spatial reference ID attached to the text. So if you want to include the spatial reference ID, then you might want to use this one here, STSEWKT or GeoJSON. We'll use some of these functions later in this course. Okay, so that's all for this tutorial, and so I hope you find this useful. Now you can really enjoy those functions provided by PostGIS to do spatial analysis with geometries, not just non-spatial data. So now you can deal with spatial data using pgAdmin, QGIS, or Jupyter Notebook. Okay, I'll see you in the next video. Take care. Bye bye.